All right, thanks, Tanzeem. I really have enjoyed a lot of all of these presentations thus far. I'm going to be really picking up where some folks have touched on in some similar areas. I do a lot of work in depression, but today I'm going to be focusing on anxiety in part because I talked a lot about some depression data last year at this conference. Are you all able to see my screen okay? Hopefully so. I'm going to be talking about using passively collected smartphone and wearable sensor data to develop contextualized indicators that are personal to an individual, and trying to use those kinds of things to understand anxiety and depression better. Or sorry, anxiety and post-traumatic stress disorder. I almost always use depression following anxiety. Sorry, old habits. This work is in part supported by the National Institute of Mental Health. I just want to say these views are my own. Today, I'm going to be, in terms of an overview, I'm going to be talking about passively collected data. Given other folks have highlighted this, I'll probably jump straight off of this. And then we'll talk about the use of this type of data to predict anxiety and post-traumatic stress disorder, so detect the severity of it and the diagnostic kind of differentiation, and then start predicting long-term changes, so things far out, and then also discuss rapid symptom changes in clinical groups. So I'm actually going to skip right over that because I think other presenters have done a wonderful job discussing the highlights of the types of data that we can gather in folks' real life with devices that pretty much most people own a smartphone, and then the amount of access to passively collected data in other forms is growing rapidly across time, and so this data is becoming more and more ubiquitous. Well, we've used this kind of data to try to predict or really detect different types of severity and of anxiety disorders and anxiety disorder symptoms. And I'm going to highlight one study first that discusses this in the context of social anxiety symptom severity, where we tried to predict social anxiety symptom severity using 2 weeks of passively collected movement data, so accelerometers on a smartphone, and then calls and texts. So specifically just timestamps, no content. Here, using this, you'd expect this to be related to, particularly call and text data, to be related to social anxiety. Social anxiety is often thought as being characterized by very extreme behavioral avoidance patterns related to social interactions. So thinking about like response latencies to incoming and outgoing texts where folks are hesitant and they might take some time or things like that. Being something what we were expecting, not picking up their calls when they're getting them, things like that of known callers. Well, we were able to use these types of data and patterns to try to then actually predict the severity decently well, predicting the majority of the variation across persons. And it was very distinct to social anxiety. So not very related to depression, and then not very related to broad classifications of negative affect or positive affect. Some of these types of data can also just generate novel insights into what is going on in terms of different biomarkers. So in this study, we expected the call and the text data to really be what's prominent in explaining or predicting these, detecting the social anxiety symptom severity of this population. But we were finding that really the majority of what our most prominent feature was actually oscillation patterns in their movement, these rapid movement patterns. In particular, what we think corresponded to their speed of walking. Folks who had a walking speed that would be sustained in kind of periods that would essentially be about 1 second, had lower levels of social anxiety symptom severity, and those who had higher levels didn't really correspond to that. Interestingly, there's some literature about walking and gait speed related to general health, and shown some other findings related to this. So it's actually not some weird one-off finding, which I was surprised by when we actually looked more into this literature. But something that was surprising to us conceptually. So sometimes we can, use these types of data to actually generate new hypotheses and test different things in terms of what might be a marker of what's going on. We've done a lot of other work. So that was an early small study with about 60 folks. This is a larger study with about 200 folks, where we were trying to see if we could use two types of GPS signals: how far folks were spending away from home and how much they were traveling per day, to differentiate like kind of a decently hard problem. Folks, everybody in the study was exposed to trauma in their past, and we tried to see if we could differentiate folks who had active PTSD from those who had just experienced trauma. So these folks may be somewhat symptomatic, but just not at clinical severity for PTSD as assessed by a clinical interview. And we were actually getting pretty good predictions. So IUCs of around 0.8 using just essentially temporal parsing of these two different features. With decent sensitivity and specificity, given kind of the reliability of our measurements. So using really good signs in terms of the detection front. So the first two studies I talked about were just on trying to detect symptom severity at like one time. You heard some of the other speakers discuss changes in these things. This is a study where we tried to use wearable movement data collected in between two anxiety disorder interviews that were about 17 to 18 years apart, and the wearable movement data occurred right in the smack dab in the middle between those two assessments. And we wanted to see if this wearable movement data with about 265 folks could actually predict the changes in who would actually experience some kind of anxiety symptom severity exacerbation of their generalized anxiety disorder symptoms and their panic disorder symptoms. And overall, our AUCs don't look that hot when you compare it to other data. You know, we've got essentially what would correspond to like our optimal cut point was 85% sensitivity and 53% specificity. But when we compared this to like active assessments that of self-reports of folks' anxiety, the AUCs were essentially about 0.5 there, completely random and could not predict future symptom changes. So we're actually, this type of data could be prognostically useful in actually detecting who is likely to get worse across a pretty large span of time. On the very opposite end, we've also done some assessments trying to see if we could predict things in rapid symptom changes. So, so far we've talked about the symptom changes that you've heard talked about from our speakers were in the duration of weeks to then decades of the study I just talked about. This study, we were trying to predict rapid symptom changes from hour to hour. So anxiety and avoidance symptoms, the majority of the variation of anxiety and avoidance symptoms actually occurs in a rapid fashion. Folks change throughout the course of their daily life, and they're not always avoiding things. They have some ramp ups of avoidance symptoms that occur within the day. And we wanted to see if we could model that. So we used personalized deep learning models. When I say personalized, I mean they are person specific or idiographic. There's a lot of different names for this, but specific to an individual. And we tried to use past data to predict the next instance, the next hour's change. And overall, we could predict a large amount of intra-individual variation. On average, it varied, the performance varied by individuals, but we had about 39% of the future changes in anxiety and avoidance symptoms explained by these types of data. And the type of data that we were collecting were all based on the smartphone. So all based on a mood triggers application that I had developed. In terms of insights, you heard a lot about geolocation data being important. We found something similar here somewhat. Geolocation data was very important, but the meaningful relationships varied pretty considerably. So these are personalized models, and you can see the the feature importance from Shapley values that we're presenting here. And each row reflects an ID, and each color reflects its importance, a given variable's importance in predicting their future anxiety and avoidance symptoms. And you can see that being indoors was pretty commonly associated with things across a number of folks. It tended to be marginally associated with social anxiety symptom severity compared to generalized anxiety disorder symptom severity. But it's really heterogeneous. Much like you've heard the groups talk about thus far, folks differ. And for one person, for example, going to an insurance agency was really what predicted their anxiety and avoidance symptoms. We expect that they probably worked there, but this just gives you a sense of not everybody experiences the same thing. And we've really tried to go into more and more personalized or personally weighted methods to try to get around this large heterogeneity across persons. That's a little bit of what my lab's been doing. I want to thank everybody in my lab that's contributed to this work, and also my collaborators, some of whom are here. So without further ado, I will shift over to Sabine.